Good morning, students. I'm Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. Today, we are going to learn on extreme important concept called optimizing logistic classifier using gradient descendant. So, until now, you learn about what is classification, and we learn how a classifier actually improves itself when it makes mistakes, as in our previous videos. And this topic connects mathematics, logic, and real-world decision making. So before moving forward, let us recall some basics. So classification means predicting categories such as in a binary result such as yes or no, true or false, like that. And we already studied logical regression, which is a sigmoid function and loss function at a base level. So today we'll see how all these components work together during training. So if you don't understand everything clearly, don't worry, I'll explain you again step by step. So objective of this session is by the end of the session, you should be able to explain what a logistic classifier is and how gradient descendant works and how model weights are updated. So you will understand why reducing a loss is the main goal of training any machine learning model. This knowledge will help you to later when you study neural networks and deep learning. So let us understand the problem using a real life example. Imagine a health prediction system that classifies patients at a high risk or low risk. So if the model weights poorly tuned, the system may misclassify patients. This can lead to false alarm or a missed risk. This is dangerous in real world systems, so the model must be optimized properly. So empathy part of today's class is from a human perspective, wrong prediction can create confusions and loss of trust. So logistic classifier outputs probably using a sigmoid function as I told you about, and if the probability is incorrect, decision will also be incorrect. So our goal is very clear: improve accuracy by reducing loss. So in defined part, the major problem we want to avoid are false alarms, missed risk, and unreliable outputs. So these problems occur when model weights are not properly adjusted. So optimization means carefully adjusting weights so that the prediction becomes closer to reality. In ideate part, you already know about what are the possible solutions to to solve our problem is. To solve these problems, use an efficient method called gradient descendant. So already there are solutions like better loss function, batch optimization, feature scaling, regularization. Among these 5 methods, gradient descent is the best method. So our supporting ideas include better loss function, batch optimization, feature scaling, and regularization. So then logistic regression is a binary classifier, as I told you many times. It first calculates a linear combination of inputs and weights. The weight is then passed through a sigmoid function to convert it to a probability between 0 and. If the probability is greater than the threshold, we predict one class, otherwise the other class. So this is the logistic regression or a sigmoid function here. So sigmoid function is smooth and differentiable. The property is very important for optimization. It converts any real world value into a probability. So the formula for sigmoid function is sigma of z is equal to 1 by 1 plus e power minus sigma. So because if it is differentiable, we calculate gradient, we need for a gradient descendant. So as I told you about difference between what is cost function and what is loss function. So loss function is there is a difference between actual minus predicted for only one data is called loss function. For throughout the whole data which we trained in data is called a cost function. The entire data set is cost function. For a single data is loss function. So here the cost function tells how wrong the model is. For logistic regression, we use a special loss function called call loss or cross-entropy loss. Our goal during training is minimize this cost function. Then this is the classification or optimization techniques of gradient descendant here. And this is the visual explanation of how slope direction of movements, that is in gradient descendant. Imagine standing on a hill and trying to reach the lowest point. You look at the slope and move downward. Likewise, with proper guiding learning rate. Learning rate is nothing but that is learning rate of a steep slope for each and every step during we travel to the from top to down. We calculate the each and every steep slope. That is a learning rate. Then types of gradient descendant are there are three main types of gradient descendant. Batch gradient descendant uses the entire data set. Stochastic gradient descendant uses one data point at a time, and mini batch gradient descendant is a balance between both. So optimizing the classifier is gradient descendant helps the classifier converge faster, creates smoother decision boundaries and reduce error rate. As training progresses, the model becomes more confident and accurate. And then application of gradient descendant is here optimizing logistic classifier are widely used in medical diagnosis, fraud detection in finance, and spam filtering in email detection and risk protection systems. So even deep learning model is intentionally used gradient descent for training. And this is the mind map of the what is optimizing classifier using gradient descendant. And there's a small activity. Here we will train a small logistic classifier with a small dataset and observe how loss reduces after each iteration. This activity helps you to understand learning a gradual improvement process. And conclusion, optimization is the key to intelligent model. Gradient descendant is the one of the most powerful ideas in machine learning. So keep learning, keep optimizing, and keep improving accuracy. So I catch you in another video. Thank you.